This is EGME-331 Solid Mechanics Prerequisite video series. In this video, we'll be reviewing the topic of internal forces. What are internal forces? Internal force is a force that acts from within the structure. That means the internal forces between the particles, let's say the molecules or atoms of a body, maintain the integrity of the body. The internal forces inside a body are directly affected by the external forces or the loads that is acting on the body. Therefore, designing a body to properly resist the external loads and maintain its structural integrity requires the complete knowledge of the internal forces within the body. Now, the internal forces in a body can be investigated or determined by plane sectioning or slicing the free body diagram of the body. Now, slicing or sectioning a body externally exposes the internal forces on the cross section of the body. Now let's take a look at what are the different types of internal forces that are commonly used for mechanical analysis. We have the normal forces. The normal force can be categorized as compression and tension. The compression is the pushing force that squeezes a material, and the compression force or the compressive forces often makes the material shorter. The length decreases. An example of compression would be to squeeze a sponge in your hand, and in this case we are creating compression. Next we have the tension. Tension is a pulling force that stretches a material. This makes the material longer, the length increases. An example of tension would be to hold an elastic band in each hand and move your hands further apart, and you are creating a tension that stretches the elastic band. The next category of internal forces is the shear force. Now the shear force is the internal force component that is tangent to the cross section. Then we have the torsion, which is a twisting or turning force. Example of torsion would be to wring out a wet washcloth. So you can use the twisting force of the torsion to twist the washcloth. So you hold the washcloth in two hands and twist it in opposite direction to force out the water from the washcloth. And the last category of the internal force is the bending force, which is a force that makes a straight material curved. So one side of the material squeezes together, we get compression, and other side stretches apart and we get tension. An example of bending would be a soft or a damp sponge that is easy to bend. Hold it in both hands and bend it in the same way, and you would be getting a bending force resulting in the structure being bent. Now the tension acts on the top side while the compression acts on the bottom side.